So good morning, everyone. Thank you for investing your time and joining us for today's panel. I'm Sharon Shahrokhi Tehrani, the product manager of machine intelligence retention team at CBC. It's an honor to be part of this panel and be your host for today's session. Today, we have an amazing panel on ML system design for constant experimentation. We will talking about architecture design, model training, tracking performance, and hearing about the implementation challenges of ML system design from experts' point of view and how to address those challenges. So our goal today is that you will come away with a new idea, fresh perspective, and a strategy that you can apply into your business and industry and be more successful in your ML system design. So here is the format to give you an idea what to expect. So first of all, we will give few moments for each of the panelists to introduce themselves, talk about their roles and their interest in this topic. Then I will kick off the panel with asking the questions. For the last 5 or 7 minutes, I will give the opportunity to you guys to ask your specific question and to gain an understanding how to navigate the upcoming opportunities and challenges in the ML system design and be more successful. So sounds good to everyone? Okay, great. So please welcome the panelists, Olga from RBC, Abhishek from H2O.ai, and Kyryl from Georgian. So I would like to start with Olga to introduce herself, talk about her role, and what's your interest in this topic.
Sure. Is it working? You guys can hear me. Okay, perfect. So my name is Olga Tsubiks. I'm the Director of Strategic Analytics and Data Science at Royal Bank of Canada. I'm responsible for the development and evolution of all the models within personal commercial banking that are related to capacity at RBC. I lead a team of brilliant data scientists, and part of the work that we do is making sure that for the models that we have in production today, the work that is ongoing is the improvement of those models. And as part of that, we run tests and experimentation to make sure that we are continuing to evolve our models, making them better and always keeping them relevant to our customers, our products, and our environment overall. I'll pass it to next.
Thank you, Olga. Kyryl, do you want to introduce yourself?
Yeah, sure. Nice to meet everyone. My name is Kyryl. I'm working as a machine learning engineer at Georgian. Georgian is a Canadian VC firm. We invest into fast-growing SaaS companies. And apart from being an investor, we also have internal R&D team where we in my team, we working with portfolio companies and help them build and accelerate machine learning product inside of their companies. So I have a lot of exposure to a different company from like low maturity company, which only starts their machine learning journey, to like high maturity companies. Some of our portfolio companies, they have like 2,000 models in production, process like million requests per day. So it's like a huge spectrum. And really happy to share some insight from our team and our portfolio today.
Thank you, Kyryl. Abhishek.
All right. Hey, everyone. So I'm Abhishek from H2O.ai. At H2O, I lead a number of different product teams. Actually, let me start by H2O. H2O is an AI cloud platform. We help machine learning engineers and data scientists build the models, deploy the models, and operate the models at scale. And we work across a wide spectrum of different types of companies, anywhere from startups to large enterprises, Fortune 5, Fortune 10 companies in the world. So my role at H2O is largely around leading product management, product development. So MLOps is one of the key elements that I work on with an engineering and design team. So everything from model management, deployment, and operations. I also lead the experiment tracking product management team, responsible AI and AI governance teams, as well as automatic documentation teams. So a wide spectrum of different product lines. And through this experience, I've worked with, as I was saying, many large enterprises that have done this at scale. many companies that are looking to experiment and build models and manage models that are learning and trying to get there, as well as many startups and early stage companies as well who have been either doing this or looking to get into it. So happy to share those insights with everyone.
Awesome, perfect. So now I want to start with the first question, and I would like to start with Olga. So where is your organization in ML system design journey? And can you share a little bit about what's going on in RBC?
Sure. So I think in terms of maturity within ML system design, RBC is at the high level of maturity. So we are a very mature organization. Having said that, there are multiple machine learning organizations within RBC that are at different stage of their maturity, and also there are multiple teams that are running machine learning, and they could also be within different levels of maturity. So, for example, one of the teams that I am responsible for is at the early stages of their journey. They were not considering machine learning as part of their work before. And so they are just getting mature. And part of that is really setting up the experimentation and design, looking at the models that they've put together last year that they now have to maintain and improve, and learning along the way. But the majority of the teams within the bank are quite mature, and they run thousands of models every day that are putting results in front of the clients. They're really at that. So it's a spectrum, I would say.
Okay, great to hear that. So how about you, Kyryl? In Georgian, where is your organization in those ML system design journey?
Yeah. So I think the Georgian itself as a company also quite mature. But because of our specifics, we work with our portfolio. Our portfolio is like a different spectrum, and it's quite interesting because on the one side of the spectrum, there's a company which only started their ML journey, and we're actually helping them, hiring their first data science, ML engineers, like you set up a process right away. And there's the other part of the spectrum, which is like the most interesting and the most challenging one, where you actually need to like embed the company and help them manage this like thousands of models. So it's like whole spectrum. We work from like just over the beginning, and like what we are trying to do as a team, we're trying to not much, but like basically bring the next level to every company. If it's company only like starting, we trying like to basically set up like a base and like introduce. So you need to monitor, you need to deploy, like the iteration speed should be fast. Or if it's like high maturity company, we trying like to basically push them towards the edge. So it's like whole spectrum. And I think at Georgian itself, it's quite mature because we can aggregate and have like a unique view of like different ML system design in the different companies, and can like see mistakes and basically like cross-reference and like have like a common crowd view.
Awesome. How about you, Abhishek, in H2O.ai? And you're managing multiple teams, so I would like to hear about your perspective.
Yeah, so just kind of talking about ML experimentation and developing the models. This, once again, not a surprise, it ranges in a wide spectrum. There are many organizations that are just kind of getting started. They're getting started with new frameworks that they're getting exposed to, scikit-learn, PyTorch, etc. So those are all frameworks that they get one data scientist on board, start using, or use some kind of an AutoML tool to get more of a junior or senior data scientist using to build models. So from that level all the way until the spectrum of there's 500 or so data scientists in an organization deploying tens of thousands of models on a regular basis. So that's like the spectrum of customers that we tend to work with. The maturity curve really kind of varies when we look at organizations like that. So the tooling that they have, the knowledge that they have, the systems and processes that they have in place, as the organization gets more and more mature, that starts to get put in place. And one thing that we try to help our customers with is how do they expedite that journey? If they're starting at the very beginning, say that level 1, how can they get to level 5 as quickly as possible? And how do we guide our customers down the right tools, people, processes in place such that they don't necessarily go from 1 to 2, 3, 4, 5, but rather go from 1 to 4 with the right processes in place and make that accelerated journey of, call it AI transformation, happen quicker.
Awesome. So now I want to go a little bit more technical. So I want to start with Kyryl. Can you share what kind of general architecture design that you are using as part of your ML system journey?
Yeah, that's an interesting question. So I think again, because of like huge variety, we start working from what company already have, but we have like a kind of a best practices and almost like our own internal tech radar. What kind of tools we can recommend? So it's all start from like infrastructure, basically. Like there's like a modern stack, like a Kubernetes, Docker, like something you can build on top of what, and then we just taking very pragmatic, very lean approach that like your iteration should be as fast as possible, and you value to like your time to delivery should be as fast as possible. And based on this, you already can choose which tool you want to use. Inside of Georgian, we use what's called RFC, when basically have like a setup infrastructure and we want to introduce some changes. This is how it happens. But I think from the like best practices, we just make sure that everything is automated. There is a good orchestration level. Delivery is fast, and like ML team is integrated with engineering team, and like you basically like do everything end to end.
Okay, awesome. So how about you, Olga? How do you approach the architecture design at RBC? Do you think anything differently or similar to what's happening in Georgian?
I think we might be a little bit less flexible. You have a wide spectrum of clients. At Georgian, we try to standardize as much as we can to make sure that we have the agreed upon approach. So we have multiple architectures that we can pick and choose from. So that would depend on your domain. That would depend on what kind of system you're trying to build. So you would look at those architectures, try to find where does your AI product fits the best and go with that architecture. Now, there are some unique cases where you want to grow that architecture and evolve that architecture, and they are not set in stone. They are evolving over time. So since I've been with the organization, they've evolved quite a bit. And what we are looking to do is to make sure that we have the appropriate level of support, the appropriate standards that our AI products are all meeting, so that we can address any kind of issues during the development or deployment when the models are in production in the best way. If those were all unique AI products with completely different architectures, and one team was running Kubernetes and another team was doing something completely different, it is hard to stay on top of all those different solutions and make sure that you support them all. So we do have to, as a very large organization of 85,000 very creative people, have to stick to certain architectures out there that we've all agreed upon and they work for us. And we continue to evolve them as well.
Okay, awesome. So we've heard about like certain architecture and how they are evolving. So Abhishek, how you are approaching the architecture design?
Yeah, so I'd say our approach is more similar to how Kyryl's doing it, working across a wider range of customers on our side. But effectively, the goal is to make sure that velocity, as you were saying, is key for both experimentation, deploying, monitoring, and retraining. That's one key element, and then the usability as well. When we look at the actual folks here, and I'm sure a bunch of you guys in the audience, you're data scientists or ML engineers, you want to focus less and less on the unnecessary stuff. As a data scientist, what you want to do is continuously experiment, build models. You don't want to worry about the infrastructure as much, or how big your cluster is, how many resources that actually requires. That ends up being something that becomes unnecessary and things you don't want to deal with, or necessary evil that you kind of have to deal with. So when we think about architecture, how do we abstract that in those kind of tooling decisions that a data scientist does not want to deal with from an experimentation standpoint, and then an MLE, what they don't want to deal with when they're deploying and managing models at scale. So when we are designing products and building out architecture, it's kind of looking at how do we enable data scientists and MLEs to do what they need to do quickly and in a very user-friendly kind of a way, and only give them the options that they want to be exposed to, and not expose the unnecessary evils to them.
Okay, awesome. So the next question, I want to go from an evolution perspective. So how your maybe start with Abhishek. Now, how your company evolved from their ML system journey when you joined them, and what's currently you are having in place?
Yeah, a really good question. So from our standpoint, we kind of think about experimentation as a very required thing at this point within the overall ML journey. When we started off the company, I'd say 10 years ago at this point, data science was still a relatively new thing. Deep learning and neural nets was becoming something new and cool at that point. And it took the industry and practitioners a little while to just kind of get caught up to it. Then came AutoML and things became slightly easier to build models on. And now we're at a point where the model building side is becoming more and more consistent. We know good frameworks, good methodologies, good tooling that is actually out there. So now that tooling is actually available in the market. Now from the experimentation side, when we look at how do we allow for users to kind of build out the models that we know generally how to do fairly well at this point, more quickly and better. That's like the tools that we're looking at developing at this point on our side and making sure our customers are adopting some of the best practices based off of lessons that we've learned as well. So it's all around kind of experimentation and getting models into production as quickly as possible in a way that is adding value to the business as well. That's what becomes at the core of the overall product and the offering that we have. So from the time, just kind of like learning evolution of how do we develop the models in a best way to how do we experiment quickly, and now how do we deploy the models quickly. So it's like an evolution, and I'm sure when deploying of models also happens, there's a good practice for it. There's going to be other problems that we start to encounter as well, and then we'll have to kind of evolve our company forward from there on whatever the next problem is. How do we do that in the most repeatable and quick way possible?
Okay, awesome. So I wonder if Olga or Kyryl wants to add to that evolution. So we heard about how fast we want to experiment, build models, and deploy them. Do you do anything differently from your starting point till today in your ML system design journey?
Go ahead.
Okay. So I think for us, in the last 5 years, the big word would be automation. So we've moved away from a lot of things that we did manually, and we just talked briefly about experiments. So running them manually, recording your results, discussing them with your team used to take a lot of time. And it was quite dependent on the developers themselves, how they do it, what are the rules that they build in, how they define the results, how they judge them. So now there are tools out there that can support that can simplify that can easily take a portion or a percentage of your traffic or your data coming in, direct that to the experiment, run, look at the results, and then make the decisions on whether to put this as part of your ML system or throw this away or send it back for another experiment. One quick shout out that I want to also make about ML maturity that we are talking about. If you haven't looked at the scales that Abhishek just mentioned, 1, 2, 3, 4, 5, Google put together ML maturity scale, so you can look at that. And also Microsoft have put together an ML maturity scale. So there are differences between them, but I suggest you look up those if you haven't already to understand where you are yourself within your organization, how and what would it look like if you were to move to the next level of maturity, and so that you can help driving that within your org.
Awesome. How about you, Kyryl? Do you want to add something?
Yeah. So I think like 2 points in terms of like evolution. So how I would like to see it, basically almost like imagine like a bias rule, right? So like you make your decision based on 2 points. First one is like your prior knowledge, basically everything you read on the internet, everything you know follows the best practice, best trend, right? And second multiplier is basically like your data points, what kind of project you done before, and this is basically 2 components which contributes. And more you done more project, more models in production, likelihood like grows, you have more knowledge there, and like more you like learn about different stuff, attend different conference, learn about tools, like more your prior growth. So like this is what changed your decision over time. And I think we done like a quite long path in Georgian, and we also see this in our companies. Like for example, one of our companies started 1 year ago. We hired first ML engineer. There was like one processes. 1 year passed. They have 12 team in data science team processes, which works there, doesn't work right now. We need to change everything. I think if I choose one, maybe like if you choose like two most important evolution points, the first one is that we don't treat model, like output of the machine learning team as a model anymore. We treat it as a pipeline. So right now your pipeline should like live independently from you, and like model weights. So basically like weights and Python class which can run this model is not enough output right now. Enough output right now is basically which reproducible pipeline. This is the first, I think, evolution. What we come up, and I think the second evolution is that local training is not good enough right now. You need to have some kind of like a third-party arbiter, like basically like a either like CI or some kind of platform, some kind of automation which produce you model use later on use into production. So this is, I guess, two main like points, evolution points we pass in a couple of last months.
Just gonna add one more thing over here. So I think automation, obviously a fantastic point, and I'm sure a lot of you guys in the audience are thinking about it also. One more thing that I encourage you guys to all think about is how are you guys putting the models into production, and what are the implications about that? I know there are lots of talks around responsible AI and governance of AI. We may dive into that in the panel, who knows? But as you are putting the models in production, you want to make sure that it is good and safe for the consumers that are actually receiving it. It's good for the society. There's actually business value that's coming out of it as well. You're not breaking any kind of laws or regulations or compliance elements. So how do you bake all of that within the overall process as well? And that's, I think, the next kind of wave. A lot of people are talking about it at the moment, but how do you operationalize that? And that's really gonna, I think, what's gonna take the company forward in the future.
Yeah, amazing topic to think about for your future. So now I want to go with and start with Kyryl. So when it comes to determining the model performance and like baselining, how do you approach it in Georgian?
Yeah, that's quite interesting topic, and I really like our process right now. So what we do in Georgian a lot is hackathons for this. So how it works is basically, and hackathon, like it might sound like on the top is basically 1 week of concentrated effort when everyone just cancels their calls and work as a team together, like on a one single model or like a single project, which is basically 1 week without any calls, just concentrating on one problem, bring like amazing results, and it's basically compressed work on several months. But it's not only 1 week. So we usually structure it in the next way. Before a hackathon, before this like 1 week of like deep concentrated work, we have maybe like a couple of weeks just to set up the requirements, understand what the problem is it like important, not important, should we even run hackathon about this? Let's say like, and this is where like our product management works, like we define ROI, we define like what the path to production would be, and most important, we build the most dumbest, simplest pipeline, simplest baseline for this problem, something on top of which you can iterate. So this is what goes before hackathon. And the pipeline might be anything. It might be rule-based. It might be like human performance. It might be like the most simpler, easier, like logistic regression model. Then we have 1 week of very concentrated effort when everyone from the not everyone from the like everyone from the team involved and work like very hard on this problem. And then we have like a post-hackathon tail where we actually work on like verifying experiments, put in model in production, basically like working like all this like closing stuff. But I think most baseline and target metrics is defined very close to the business and business case before hackathon. So we go in like modeling part already with like some performance and some numbers.
Okay, that's an interesting model to follow. You have like a focus time to decide about the baseline and model training. So Olga or Abhishek, how do you guys approach that piece of work in your organization?
Yeah, so one example I can share is with one of our customers, a very large financial institution, global institution, having a conversation with them. They've got obviously hundreds of data scientists on staff, and they wanted to get the team of data scientists to build obviously the best model. What they ended up doing was have a team of data scientists build out a model for a particular problem, a particular use case. And then they also had some junior folks build a model with AutoML tools. And really with the AutoML tools out there, you can very quickly see what that performance difference ends up being between a model with a bunch of senior data scientists and then AutoML tool, what that actual comparison ends up being based off of the particular metric that you're looking at, if it's any specific accuracy metric or other metrics that are part of it. And then you're able to really kind of compare a team of like each individual data scientist, the models they produce and based off their experimentation and parameter settings versus something that was done automatically. So I found that to be like an interesting approach as well, doing like a human versus a computer way of comparing.
So Olga, do you want to add something?
Both of those I think are very interesting and innovative ideas that I'll definitely be taking away. I think from my answer to this will be very short. A lot of the models have different performance. You would expect different performance from an NLP model versus a regression model. And when it comes to judging what the baseline should be, it comes to the experience of the data scientists on the team that are designing that model. They know what the baseline that they are expecting of themselves is. And then we have a process on our team around continuous improvement. So we are reviewing the baseline and we are reviewing models on a regular basis and looking if they are missing those baselines now, they're not delivering on their targets, and then going into what we call brainstorming, but we could call it hackathon too, and looking if there's anything we could do to improve that and what is driving that deterioration in performance, or if the performance is good, could we push it this year with all the new stuff that we have.
Okay, awesome. So as a follow-up for you, Olga, I know you touched base on the performance. How do you select the performance and tracking in your system designs? I know you mentioned part of it comes from a data scientist to decide about the performance, but what else you put into action for that piece?
So I would speak very specific to my team and the work that we do, which the work that we do results in significant investments by the bank. So when you are having a large sum of money on the line, you have a certain expectation from the business side on what the performance metrics should look like. So the one piece would be to work with our business to understand what are their expectations, what they see as the ideal output of all of the AI product or ML system, not necessarily a particular specific model. Then we are looking at system performance metrics. So we are looking at all the systems, are they online? What is our downtime? We are tracking things like model accuracy as part of ML and engineering. We are tracking the pipelines. What is the rate that the data is coming in for the streaming data? If it's a batch data, then what is the rates of our job failures? There are lots and lots of metrics that different teams look at. So it's also about how your team is structured. So engineers are looking at the data pipelines that are powering machine learning, and they have their KPIs. We have ML ops teams that are looking at the special pipelines that are the same as other ETL's pipelines, but they have that ML component to them. So they're looking at number of models retrained and the health of the training data, the health of the model overall. And then we have the product owners that are looking at the AI system overall and how it's meeting the business need. What is that output? If it feeds some kind of UI, what does that output look like? And if it feeds another system, then it goes in as an input and they start judging it as a data. You know, what are we getting the expected amount of data? Are we getting it at the rate that we expect, etc.?
Okay, awesome. Lots of things to consider when it comes to the performance and tracking. I wonder if Kyryl or Abhishek wants to add to those metrics as well.
I'll just add one more thing over there. So one good way, and just kind of bouncing off of Olga's point, when you are looking at the overall model's business impact, one really good way to do it is through A/B testing of models, which is effectively have multiple models in production and direct some amount of traffic into each of the models, and then see how your actual business metric is improving based off of that. For example, if you're looking at a marketing campaign and you're trying to improve the overall click-through rate, then you want to be able to see, is model A doing better or B or C? And then test that all out in production in real time, because an accuracy metric is not necessarily going to tell you that. or a latency metric's not necessarily going to tell you that. It's got to be a business metric that tells you how effective is the actual model in your business context. And even if model A has lower accuracy, but is yielding a higher click-through rate, that's fine. That's what works for the business. And that's what you should end up promoting as like the main model that takes 100% of your traffic. So important to kind of distinguish between an ML metric, an infra metric, and actually the business metric.
Yeah, makes sense. Just to reinforce on this point. So what main metric for us, and I think it's important because we have like a lot of companies, and like our team is quite small. We have like only seven full-time people in a team, and potential like unlimited amount of project. So how we choose on what to work on for like the next couple of months, it's basically we're trying to calculate ROI, return of investment, like right by investing like 6 months into the project, what the like valuation of the company would be after this. This is a primary metric we optimized. We usually not go to implementation and work if we don't have like a business metric defined, like success defined in the business metric. And once you have this, if you able to match your machine learning metric as a proxy to it, congrats, you like a happy person. You can work, you can iterate, you can like calculate F1 score, whatever you calculating, and like you kind of hope you hypothesis that you understand how it's influence ROI and business metric. And after that, yeah, it's basically like a system level metrics that basically making sure that SLI is there, solution is working, etc. But this is basically 3 level, ROI plus business. Congrats if you have your ML metric correlate with this, and then system metric making sure that you basically alive.
Okay, great points here. So I want to stay with you, Kyryl, and ask you this question. What is the greatest challenge in implementing ML system design that you experience, and how did you address it?
Yeah, I would say there is a lot. There's a lot of them. But I would say the one which we advocate, try to change, and we see as a main the main stuff which holds you back is like speed of iteration, and like as a result. But basically, what causes speed of iteration is the greatest challenge we saw in our portfolio companies. It's when data science team or the team which produce models is isolated from engineering team. So this is, I guess, one of the biggest problem, and one of the biggest. It's almost like a cultural and not technical challenge, right? Because depends on your maturity. Like you might use Kubernetes, you might use managed solution. It's like it doesn't actually matter, but your team should be end to end, and basically just making this transition from like if company already like operate for like 10 years, like ML is quite new for it, making sure that you embed this function into the company, embed it naturally, and data science team is actually owning production. They shouldn't be like an expert of infrastructure, etc., right? But they should be around, and they should be self-serve. Almost like 80% of your problem you should solve without involvement, like heavy involvement, like maybe infrastructure team or like someone from engineering. So I think defining this kind of culture and making sure that data science team is not isolated, it knows what it's doing, and it's integrated into production. This is, I think, one of the biggest challenge we're trying to solve, and like try to influence every company in our portfolio company have a culture like this.
Okay, so we heard about the culture as probably one of the challenges. How about you, Olga? One of the greatest challenges that you faced in RBC?
Oh, the greatest. That is. How do I pick?
Just do your.
Okay.
Which metric would you use for greatest?
Yeah,
exactly.
That's the criteria.
I think this is a great question. So one of the challenges that I face in my work, because I lead people, is converting the business problem into a machine learning problem and then solving it end to end. So I'll give you an example. I was talking to an executive, and he said, I have all of those dashboards and all of this information coming at me, and I really can't drill through it. I'm not an analyst. I don't have time for this. And there are hundreds and hundreds. So I give it to my EA to deal with. And that is not a great way to do it. And so I thought, okay, how can we help you with machine learning? How can we help you solve this challenge? So it is a very vague problem that he defined to me, but it is a very common thing that they do. They give you extremely vague problem that they see in a more specific way that they can do it, but that's not enough to translate it. So then I turn to my team and I say, how can we translate this into machine learning problem? What do we have? We have the data, because they have the dashboards and reports. So we do have the data. How do we ingest it from the existing systems in the form that they already have? Then what machine learning algorithms can we use to pull the most important pieces of information that this gentleman is should be concerned about, should be aware about? So then I looked at how he works. It's important to understand your users. I'm a very big believer of sitting down with them and looking. If you can, it's a luxury for a data scientist. So I sat down with him and looked at how he works through the data. And I sat down with a couple of other people. And there are 4 different approaches that they used. I gave a talk about it in a machine learning summit in Toronto last year. One of them looked at quarter over quarter. This changed. Why did it change? Dennis, why did it change? What's going on? That's how they work. They are very action-oriented. So they need the machine learning information and output that can take them to action in a second. What font, who do I call? How do I solve this? That's what they're thinking of. So then we have other people that are looking at anomaly. This is weird. You know, if you can relate to any of this, like you look at the patterns, if you've been long enough around, or maybe you're looking at, this is weird, I didn't expect that, this is concerning me right now. And then we had other things. People are looking at, oh, look, this went up and this went up. That's related. So how do we take those different personalities of how people work with information and convert that into an AI product that can simulate that thinking? So I'll give you one example. So he was looking at anomaly. This is weird. I've never seen this number so high before. That's an anomaly detection. We can solve this with machine learning. We have that. If you're looking at changes over time, we have models today that can look at information over time, predict what it should be, and then look back at what it actually is and see if that was expected. That's basically how we work. I predict my portfolio, my stock portfolio, to be at a certain number tomorrow because I have my baseline. When I look at it, it's not what it is. I'm upset or happy, depending on which way it went. So that's the kind of challenges that I face all the time. How do we take a very vague ask, propose a machine learning solution, and then actually deliver it in a very short period of time?
Awesome. And for the sake of time, I would like Abhishek to briefly share what's your greatest challenges and how did you address it?
Yeah, I think just kind of bouncing off of Olga's point, one challenge, not just in ML, I think overall in tech, is to be able to see the end-to-end picture and complete that overall goal. The challenge with ML becomes there are so many different people that are involved, data scientists to MLEs to DevOps to infrastructure engineers to backend developers, front-end engineers. So there's like a wide stack of different folks that are involved, and each of them have their own responsibility. Data scientist builds a model, MLE deploys a model, DevOps makes sure the infrastructure is there. Then there's like front-end or backend integration. And then you kind of lose sight of like, what are we actually trying to do at the end? And you can claim success at many of these different components. And a data scientist will be like, I created a really accurate model. Emily will say that I've deployed the model, it's up and running, infrastructure is available. But ultimately, if that end user experience, whoever that is, internally as an executive or externally as a consumer or customer that you've got, if that is not getting used and that is not delivering the value that it needs to, then the entire stack needs to kind of go back and rethink that overall problem. So a system design challenge is really around how do you translate that context of the end user experience that you're trying to deliver and the end business value that you're trying to deliver all the way back and make sure that that is happening in each of those steps. And each team member and each tooling is able to connect all the dots together to be able to provide for that.
Okay, so 3 main points to consider: culture, how to translate the business problem to ML problem and deliver it, and finally the end-to-end picture. So now I would like to open the floor for you guys to ask a question from our panelists in the ML system design, and we have someone here.
For the consultants, how do you deal with intellectual property rights? So obviously a lot of the work that you're doing is a competitive Is it owned by co-owned? How is that handled?
Yeah, I imagine it's a question for me, right? So yeah, we just don't call us consultants because first of all, our company not paying us, right? We already investor into them, and we not act as a consultant because first of all, IP always stay within the company. So we don't own IP. It stays within the company, and most importantly, we never come and like do some solution which they cannot manage after that themselves. So we only enable or accelerate what they already might do, and we always look for like a champion or like a team which can then manage and like support this solution. So it's not being like you invite some kind of third-party consultant, pay them a lot of money, they do like a great product, and after a year and a half, you don't know what to do with it because something is broken and your team is not mature enough to support it. So this is a situation we would like to avoid as much as possible, and we just trying to uplift not only like the technical solution but the team itself. But direct to your question, like IP is stay within the company, we don't own it.
Okay, we are at time, so feel free to reach out to our panelists during the lunch and ask your following question if you have any in the ML system design world. And thank you for your attention and time today participating in the panel. And yeah, enjoy the rest of the summit. Thank you.
Thank you.